Welcome to The Deep Dive, the show where we take a stack of sources, research, and notes and distill them into the most important nuggets of knowledge and insight, just for you. Today, we're plunging into a topic it's been completely revolutionizing the digital landscape. Generative AI. We've all been captivated by the incredible ability of large language models, LLMs as they're called,
Yeah.
to create just astounding text, vivid images, even complex code. It really does feel like a new era for artificial intelligence. But, if you've been listening to the chatter or maybe even tried playing around with these models yourself, you've probably bumped into some of their common challenges. Things like hallucinations, where the AI just sort of makes stuff up. Or the frustrating reality that their knowledge can be quite outdated, limited to whatever data they were last trained on. That training data is often just a static snapshot of the internet, which means these incredibly powerful brains can sometimes feel like they're stuck in a time capsule. This reliance on static information and that tendency to invent facts, well, it's really been Gen AI's Achilles heel, especially when you think about real-world business applications.
And that's precisely the problem we're diving into today. While LLMs are undeniably powerful for creating novel content, their true effectiveness, especially in specific dynamic business scenarios, it's deeply tied to their ability to access and use current, accurate, and crucially domain-specific data. Without that grounding, their revolutionary power can, frankly, fall flat. It can lead to outputs that simply aren't trustworthy or relevant enough for practical use. And this is exactly where the genai-databases-retrieval-app project comes in. It offers a really compelling blueprint to bridge that very gap.
Okay, right, let's unpack this then. Our mission today is to explore this genai-databases retrieval-app project. Think of it as a meticulously designed blueprint for building truly production-quality Gen AI applications. Its core purpose is really to demonstrate exactly how you can integrate these powerful LLMs with cloud databases in a way that makes them reliable and genuinely useful. We're going to be exploring two key techniques that tackle those limitations of standalone LLMs head-on: Retrieval Augmented Generation, or RAG, and the ReACT framework. These aren't just technical terms. They are really the foundational pillars for building trustworthy AI.
Indeed. And just to give you a strategic overview of how it's built, we'll break down its architecture into three distinct yet really intricately interconnected components. There's the application layer, the retrieval service, and the database layer. Understanding this modularity is, I think, crucial, as it's the very foundation for achieving scalability, robust security, and peak performance in real-world enterprise deployments.
And to make it all tangible, we'll give you a preview of a practical demonstration embedded within the project itself, a fictional customer service assistant for an airline called Cymbal Air. This is where you'll see these kind of abstract concepts really come to life, solving real-world customer queries with surprising intelligence.
Yeah, and our goal for you by the end of this deep dive is not just to understand what RAG and ReACT are, or what these architectural layers represent. It's really to grasp why they're absolutely crucial for building trustworthy, practical, and truly intelligent Gen AI solutions. Solutions that can handle complex tasks and integrate seamlessly with the kind of data infrastructure you already have. You'll understand how to ground that incredible generative power in factual reality, making it a reliable asset for, well, pretty much any organization.
Okay, let's start with the foundation. We've touched on generative AI, but let's maybe nail down its place in the AI landscape a bit more. Gen AI truly represents a transformative shift in artificial intelligence. Historically, AI was often about classification, categorizing things or predicting outcomes based on existing patterns. But Gen AI, it uses these deep learning architectures, most notably those incredible transformer-based large language models, to actually create novel content. We're talking about generating high-quality text like articles or creative writing, but also helping to generate images, code, even audio. It's that creative aspect, the ability to produce something entirely new, that makes it so revolutionary.
And this inherent strength, the very ability to create new information, paradoxically introduces one of its greatest challenges. If this creativity is left unconstrained, especially when you're dealing with specific real-world data, it can easily lead to outputs that are factually incorrect or completely irrelevant. What's fascinating here is that Gen AI's capacity for novel content creation, its greatest strength, also introduces its greatest vulnerability without the right grounding. This is precisely why frameworks like RAG and ReACT aren't just nice-to-have enhancements. They are fundamental necessities. They're designed to ensure that the generated outputs are not merely creative, but are also factually accurate and contextually relevant for practical business applications. They effectively anchor Gen AI's creative power in reality.
So if Gen AI sometimes leans on its imagination a bit too much, I remember asking my smart speaker for a summary of current events once, and it gave me a recipe for a gourmet sandwich instead. How do we keep it grounded? Here's where it gets really interesting. To tackle these issues of hallucinations and outdated information, we turn to Retrieval Augmented Generation, or RJG. Think of it as giving the LLM a highly intelligent research assistant, one that goes out and finds the facts before the LLM even begins to formulate its response. It combines the LLM's brilliant ability to generate with the grounded reliability of traditional information retrieval systems like advanced search engines, or maybe more importantly for our discussion today, powerful databases.
Exactly. The RLGI process typically involves a few critical steps. First, there's the retrieval and pre-processing phase. This is where sophisticated search algorithms query external data sources. Could be anything from vast web pages to carefully curated internal knowledge bases, or, a variety of cloud databases. Once the relevant information is retrieved, let's say a specific document or a snippet of text, it undergoes pre-processing. This involves getting the information ready for the LLM to read and understand, basically tidying it up, breaking it into bite-sized pieces so the AI can process it most effectively. Then comes grounded generation. This is where that pre-processed retrieved information is seamlessly incorporated directly into the LLM's context. By giving the LLM this augmented context, it gains a far more comprehensive understanding of the topic at hand. This enables it to generate responses that are not just creative, but also far more precise, informative, and truly engaging because they're based on verifiable facts. Now, a critical component in this entire process, especially for the kind of applications we're discussing today, is what's often called the vector database revolution.
Vector databases.
Vector databases are pretty essential here. Imagine your user query and all your stored data are translated into a kind of digital fingerprint
Okay.
that captures their true meaning, not just the words themselves. We call these fingerprints embeddings.
Embeddings, got it.
And why are they so vital? Because instead of just looking for exact keyword matches, vector databases can find conceptually related results using something called an approximate nearest neighbor, or ANN, search. Think of it like finding other fingerprints that are conceptually similar, even if they don't match exactly. This dramatically improves the quality and relevance of the context given to the LLM.
And the benefits of ARG are really compelling, as our sources highlight. First, it provides access to fresh information. This is huge because it directly overcomes the LLM's limitation to static, pre-trained data, allowing it to provide truly up-to-date information.
Absolutely crucial. Second, there's factual grounding and reduced hallucinations. This is a direct mitigation of those notorious Gen AI hallucinations, making responses far more trustworthy by rooting them in externally provided facts. Third, you get domain-specific responses. RAG enables LLMs to deliver contextually relevant answers that are precisely tailored to proprietary or highly specialized data unique to an organization. And finally, it offers significant efficiency and cost-effectiveness. It's often far more agile and cheaper than constantly fine-tuning LLMs for new or updated data because you're not modifying the model itself, you're just updating the external knowledge base.
Yeah, and if we connect this to the bigger picture, R8 fundamentally shifts the paradigm. It moves away from endlessly training LLMs on massive, ever-growing data sets to treating them to reason and retrieve information effectively from specific, current knowledge sources. This agile approach isn't just about speed. It drastically transforms the cost model of keeping AI models up to date. Instead of, multi-million-dollar retraining cycles every time your product catalog or internal policies change, you're simply updating a database. That offers a phenomenal operational and financial advantage. And the emphasis on vector databases within a RAG further highlights the critical role of semantic search over traditional keyword search. It's about understanding the meaning behind queries, leading to far more accurate and helpful responses.
Okay, so if Argy is giving our AI its factual compass, helping it know what is true,
Right.
then our next stop, ReACT, is all about giving it the smarts to figure out what to do with that truth. This moves LLMs beyond simple text generation into dynamic problem solving, creating a truly agentic AI.
That's a great way to put it. ReACT operates through a structured, iterative pattern called the thought-action-observation loop. It's really quite ingenious, much like a great chef plans a meal, perhaps. First, the chef has a thought. What recipe am I making? What ingredients do I need?
Okay.
Then they take an action, check the fridge for eggs. Based on what they observe, say, no eggs. They form a new thought. Okay, I need to go to the store. And then another action, go to the store. This loop continues until the meal is complete.
Nice analogy.
Similarly, with an LLM, in the thought phase, it verbalizes its reasoning steps, almost like it's thinking out loud. This is often powered by chain of thought, or the COTI, prompting, which helps the LLM break down a complex, overarching task into more manageable subtasks. Following a thought, the LLM determines and executes a specific action. This involves calling external tools or APIs. It could be a search API to gather more information, a mathematical tool for calculations, or, crucially for our discussion, querying a database via a retrieval service. After an action is executed, the LLM receives an observation, essentially the results of its action. It then processes this observation to inform its subsequent thoughts and actions, effectively closing the loop and moving towards the goal.
And our sources break down the key components of ReACT really clearly. At its core, you have the LLM, which acts as the brain, generating those reasoning traces and actions. Then there are the tools, which are those external interfaces, like a search API or a math tool that the LLM uses to interact with its environment and gather information. Crucially, there's chain of thought, prompting, which guides the LLM to break down tasks into those manageable subtasks through verbalized reasoning. And finally, there's ReACT prompting itself, which is the specific technique that instructs the LLM to follow this iterative thought-action-observation loop and utilize those defined tools.
The advantages of ReACT are, well, numerous. It offers remarkable versatility, meaning it can be configured with a wide variety of external tools and APIs, making it adaptable to countless scenarios. It also has incredible adaptability, dynamically adjusting its approach based on new information or the results of previous steps, even learning from past interactions in some implementations. Then there's explainability. Because the LLM verbalizes its reasoning process, that thinking out loud part, it's far easier to follow its decision-making.
That transparency must be huge for debugging.
It's incredibly helpful for debugging, optimizing, and just building trust in the AI. It allows developers and even users to see why the AI made a certain decision or took a specific action. And finally, by combining CoT with external information sources, ReACT significantly improves accuracy and further reduces those pesky hallucinations. This raises an important question, though. How does this fundamentally transform LLMs?
Right.
It shifts them from being passive responders, simply generating text based on a single prompt, into active problem-solving agents. This shift is crucial for building applications that go beyond simple question answering to perform complex, multi-step tasks that require interaction with external systems. In essence, ReACT allows the AI to mimic human-like planning and execution. It's not just retrieving information, it's deciding what information it needs, how to get it, and how to use it to achieve a specific goal. This is really a game changer for building truly intelligent assistants.
Now, let's talk about the unsung heroes of GenAI databases. I mean, while LLMs are the ones generating all that amazing content, their accuracy and relevance for any specific use case heavily relies on accessing and leveraging external data that's stored in various databases. You can think of databases as the foundational knowledge repository that grounds the LLM's creativity in reality. They're not just a storage locker, they're really the critical lifeline for informed decision-making by these AI models.
Exactly. And in robust GenAI systems, like the genai-databases-retrieval-app project we're exploring, you almost always see a multi-database approach. This isn't accidental. It's a crucial design choice because it recognizes that different types of data and different kinds of queries actually benefit from specialized storage solutions.
So not a one-size-fits-all situation.
Definitely not. It's a more mature understanding of diverse data needs. This strategic approach optimizes for performance, accuracy, and scalability by intelligently routing queries to the most appropriate data store.
So let's break down the specific types of databases mentioned in our sources and how they play into these intelligent GenAI workflows.
Sure. First, and critically important for AGI, are vector databases. As we touched on earlier, they are absolutely essential for semantic search. They work by converting user queries and documents into these high-dimensional embeddings.
Those meaning fingerprints.
Exactly, those mathematical representations that capture the meaning. Then they perform similarity searches to retrieve semantically similar text or knowledge snippets. They're optimized for approximate nearest neighbor, or ANN, searches, making them incredibly adept at finding conceptually related results even if the exact words used in the query aren't present. This is vital for nuanced natural language processing tasks because it allows the LLM to understand context, not just keywords. Next up, we have relational databases, often alongside tools like Elasticsearch, ES. These are exceptionally well suited for structured data.
Structured data, like tables and spreadsheets.
Precisely. Think about customer profiles, system logs, product descriptions, or in the case of our demo, flight schedules. They allow for the efficient retrieval of specific organized information based on known fields. Elasticsearch, in particular, is often used for monitoring and analyzing logs, providing detailed insights into system behavior, but it's also excellent for full-text search over large, structured datasets. And finally, our sources mention knowledge graphs. These are particularly useful for handling complex queries that involve relationships between entities.
Relationships, like how things are connected.
Exactly. They provide a structured way to represent interconnected information, which is invaluable when you need to understand not just facts, but how those facts relate to each other. For example, understanding a company's organizational structure or the intricate dependencies within a supply chain.
So let's test this. If I were to ask the Cymbal Air assistant, what flights are headed to NYC tomorrow, which database would handle that? And what if I immediately followed up with, where can I find a good restaurant near the airport that serves vegan food? How does it know where to look?
That's a great pair of questions illustrating intelligent routing. The first query, what flights are headed to NYC tomorrow, would almost certainly be routed to a relational database.
Because it's structured data.
Exactly. Flight schedules are classic structured data. They have defined columns like flight number, destination, time, and so on. Very predictable retrieval.
Huh.
But then for where can I find a good restaurant near the airport that serves vegan food, that would likely leverage a vector database.
Because it's about meaning and location.
Right. It's a semantic, location-based query where the meaning of vegan food and near the airport is more important than exact keywords. Maybe the restaurant description mentions plant-based options instead of vegan. The vector database can still find it. This illustrates the power of intelligent routing. An effective RA system doesn't just use one database type, it combines these multiple database types, allowing each to contribute its unique strengths in the context of specific queries. This intelligent routing is key to optimizing performance, ensuring faster retrieval for specific data types, and enhancing accuracy by querying the most relevant data source. The sophisticated retrieval layer is really a hallmark of a robust, production-ready architecture. It knows precisely where to look for the right kind of information, making the system incredibly efficient and accurate.
Okay, now let's really get into the nuts and bolts of the genai-databases-retrieval-app itself. It's structured around these three core components, each with a distinct yet interdependent role. You mentioned this modular design is very deliberate, right? Contributing to robustness and adaptability, especially for bigger enterprise deployments.
Absolutely, it's key.
Let's start with the application layer. You describe this as the orchestra conductor or the primary interface. It's where I, as the user, submit my query and it seems to manage the whole show.
That's right. The application layer isn't just a simple front end, though. Think of it more as the mission control for the whole system. This layer is tasked with receiving your query, then intelligently deciding when it needs to call out to the retrieval service for RAG. How to construct the prompt for the LLM, using both the data it gets back and the LLM's own reasoning steps guided by ReACT.
Okay.
And also when to trigger external actions as part of ReACT's acting phase.
So what does this all mean for someone interacting with the AI? It feels like this application layer is the central director, making the whole Gen AI workflow smart and coordinated.
Exactly. It's the brain deciding the plan of action, orchestrating all the other components to deliver a coherent, accurate response. It manages the whole conversation flow.
Okay, next up is the retrieval service. You called it a crucial intermediary component. It sounds like it provides the application layer with specific actions, sort of bridging the gap to the databases.
It is a critical bridge, yes. And here's where a really key architectural decision comes into play. This service runs separately from the main application.
Separately. Why do that?
Well, this isn't just a technical detail. It's a design choice rooted in principles of modularity and microservices. And it yields several significant advantages, especially for robust, production-ready systems. First, it generally leads to better recall for the LLM. LLMs actually perform better when they're given smaller, more specific tasks. So, by mapping a particular action, say get airport amenities or find flight schedules, to a predetermined optimized query within the retrieval service, the LLM's ability to effectively leverage external information is significantly enhanced. It gets exactly what it needs cleanly without having to figure out the database query itself.
So it simplifies the job for the LLM.
Precisely. Second, there's better scalability. Because it operates as a separate service, multiple LLMs or multiple instances of the main application can use it concurrently. This independent scaling capability is absolutely paramount for production environments. It lets you use best practices like connection pooling and caching, which dramatically improve throughput and resource use. It means it can handle a huge volume of queries without bottlenecking the main application.
That makes sense. You can scale the data access part separately from the AI thinking part.
Exactly. This decoupling also means the retrieval logic can be optimized for I/O-bound database interactions, entirely separate from the computational demands of the LLM application, leading to a much more efficient overall system. Third, and this is critically important for enterprises, it provides better security.
How so?
An intermediary service like this offers a robust layer for managing authentication and authorization through standard secure channels. This is vital for mitigating potential jailbreaking attacks on LLMs.
Oh, right, trying to trick the AI.
Exactly. By preventing the LLM from having direct access to sensitive database credentials, it enforces strict access controls, acting as a secure gateway that protects proprietary and confidential information. This modularity is really a hallmark of modern, resilient software design, making the application truly suitable for demanding enterprise environments where data security is absolutely non-negotiable. It acts as a hardened security perimeter.
That makes a lot of sense. And the project highlights the flexibility here too, allowing deep customization, right?
Yep.
Connecting to different services, different databases. Businesses aren't locked into one specific vendor.
Precisely. This flexibility allowing customization of how it connects to various services and databases. It indicates a highly extensible and, importantly, database-agnostic architecture. Enterprises often operate with a complex, heterogeneous data landscape, data stored across various systems, cloud providers, on-premise.
Yeah, legacy systems everywhere.
Exactly. The ability to swap out database providers or define new ways for the LLM to interact with data means this genai-databases-retrieval-app can be adapted to virtually any existing data infrastructure.
Yeah.
This significantly lowers the barrier to adoption for companies that already have established diverse data systems. It makes it a very practical and future-proof solution.
And finally, we come to the database layer itself. This is, quite simply, the foundational knowledge repository for the entire genai-databases retrieval app. It's where all the data lives that the LM uses to answer questions and ground its responses.
Indeed. Databases are just indispensable in these GenAI workflows. They provide historical context, they enrich responses with proprietary enterprise knowledge, and they're absolutely critical for ensuring overall accuracy. They empower AI models to make informed decisions by providing access to both structured and unstructured data. And a notable feature of this project's design is the interchangeability of this database component.
Interchangeability.
Yeah, well, the project provides sample CSV data for a quick demo. It explicitly allows users to run the demo with their preferred database technology.
Why is that interchangeability such a big deal for businesses that are already heavily invested in their existing data infrastructure?
It's a highly strategic design choice. It really underscores that the core value of this project lies in the architecture for integrating GenAI with any database, rather than being tied to a specific database technology or vendor. For enterprises, this flexibility is vital. They rarely start from scratch and typically have extensive existing data infrastructures, often built up over years.
Right.
By making the database interchangeable, the project demonstrates that its GenAI integration patterns are broadly applicable and not vendor-locked. This promotes wider adoption and proves the robustness of the RH-quick-going ReACT architecture itself, independent of the underlying data store. It basically means you can bring your own data in your own existing systems and still leverage this powerful GenAI framework without having to undertake a massive, costly migration or restructuring of your foundational data.
Okay, so we've covered the core ingredients, RAGRI and ReACT, and the foundational architecture with its 3 layers. Now let's bring it all together. Let's take you on a step-by-step journey of what happens when you, the user, submit a query through this system. Let's see how all these components orchestrate that intelligent response.
Okay, sounds good. The journey begins when the user initiates a query through the GenAI application, which is handled by the application layer. You might ask something like, what flights are headed to NYC tomorrow? Or maybe something more semantic like, where can I get coffee near gate A6? The query processing by the application layer then takes over. To facilitate that semantic search, the kind that understands the meaning of your question, your query is often converted into embeddings.
Right, those mathematical meaning fingerprints again.
Exactly. Next comes intelligent retrieval via the retrieval service. The application layer, guided by the LLM's reasoning capabilities, which is a core function of the ReACT framework, then makes a call out to the retrieval service. The retrieval service intelligently queries the appropriate database or databases. For instance, it might hit a vector database for that semantic search about coffee near a gate, or a relational database for structured data like flight schedules.
Using that intelligent routing we talked about.
Precisely. It retrieves the most relevant pieces of information, often called the top K passages or documents, that closely match your query's intent. This retrieval step is fundamental to Retrieval Augmented Generation, RAG, as it grounds the LLM's responses with real-time or proprietary knowledge. It ensures it doesn't rely solely on its potentially outdated pre-trained data, and in advanced scenarios involving multiple languages, the LLM might even first translate your query before retrieval and then translate the generated response back into your target language. The augmented context is then sent to the LLM. Those retrieved facts and documents are seamlessly incorporated into the large language model's input prompt by the application layer. It's like giving the LLM specific notes for the question. With this augmented context, the LLM then performs reasoning and generation. Operating under the guidance of ReACT's thought-action-observation loop, the LLM processes the query and generates a precise, informative, and engaging response. And here's where ReACT truly shines. It allows the LLM to dynamically adjust its approach. If its internal reasoning determines that further information or interaction is necessary to fully answer your query, maybe the first batch of retrieved info wasn't quite enough, it might perform multiple retrieval steps or other actions.
So it can decide it needs more info and go get it.
Exactly. This creates a sophisticated orchestration of intelligence. The LLM, through ReACT, is not merely a passive recipient of data. It becomes an active participant in determining what information is needed and how to retrieve it. This makes the entire process dynamic and highly adaptive rather than a fixed, rigid pipeline. Finally, the response is presented to you, the end user, by the application layer, hopefully, a cohesive and accurate answer that combines the LLM's generative power with real, current data.
So what's the big takeaway from how RAG and ReACT work together in this flow? How do they really synergize? Is one more important than the other, or is it the combination?
It's definitely the combination. The combined application of Retrieval Augmented Generation and the ReACT framework within this architecture creates a profound synergy that significantly elevates the capabilities of large language models. RAG's primary contribution is providing that crucial factual grounding. It ensures the LLM's responses are accurate, current, and rooted in external real-time data. This directly addresses the problem of LLM hallucinations and outdated information, making the AI's responses trustworthy.
Okay, so RAG handles the factual basis.
Exactly. Complementing this, ReACT provides the essential reasoning and action capabilities. It empowers the LLM to break down complex tasks, to interact with external tools, including the retrieval service itself, and to adapt its approach based on observations from these interactions.
So ReACT handles the how to use the facts and achieve the goal.
Precisely. Together, RAG ensures the LLM has access to the right information, while ReACT ensures the LLM uses that information intelligently to achieve a specific goal, potentially through a series of iterative steps. This combined RAG and ReACT approach represents a significant advancement. It shifts the paradigm from simply viewing an LLM as a knowledge base to considering it an intelligent agent equipped with external tools and grounded knowledge. This is the core innovation enabling truly production-quality GenAI applications that are both factually reliable and capable of complex real-world interactions. The synergy is profound. I mean, think about it. Without RAG, ReACT's actions might be based on imagined or incorrect facts.
Right, acting on bad info.
And without ReACT, RAG would primarily just facilitate single-turn generation, lacking the ability for multi-step reasoning or external interaction.
Just spitting back retrieved facts, maybe.
Kind of. Their integration creates a truly agentic system, one that can reason, act using tools like the retrieval service, learn from observations, and ground its outputs in real-world data. This makes it perfectly suited for intricate enterprise workflows like customer service or complex research tasks. This dynamic interaction between reasoning and acting is the true power that elevates this application beyond simple chatbots.
All right, let's make this concrete. The genai-databases-retrieval-app project doesn't just talk the talk. It walks the walk with a really compelling real-world demonstration. It introduces this fictional passenger airline customer service assistant called Cymbal Air. This AI chatbot is designed to provide comprehensive assistance to travelers, helping them manage flights and find detailed information about Cymbal Air's hub at, I believe, San Francisco International Airport, SFO. It's a direct, practical example of the system's capabilities in action.
Yeah, the Cymbal Air demo vividly illustrates how a GenAI application, when robustly augmented with external data, can deliver accurate and relevant responses to specific real-world queries that necessitate up-to-date or proprietary information. It showcases several practical use cases and demonstrated capabilities quite well. For instance, in terms of airport amenities, you can ask it questions like, are there any luxury shops?
Yeah.
Where can I get coffee in your gate A6? Or where can I find a gift?
Okay, typical travel questions.
Right. These queries highlight the application's ability to retrieve specific, location-based information about airport facilities and services. This is incredibly useful, showing how you can connect LLMs to dynamic knowledge bases that reflect changing real-world conditions, like new store openings or gate changes. It also demonstrates its capability with flight information. You can ask questions such as, what flights are headed to NYC tomorrow, which showcases its capacity to access and process structured, real-time data like current flight schedules. And importantly, this is not static information. It's pulled live or near live from the underlying databases, ensuring the passenger gets the most accurate information available at that moment.
That's incredibly powerful. But let's push this a bit. What if a passenger asks something really complex, something multipartal, like, say, my connecting flight to Seoul was canceled because my earlier flight to Tokyo was delayed. Can you help me find the next available flight to Tokyo and then also suggest hotels near the Tokyo airport in case I'm delayed overnight, and perhaps find me a restaurant there that serves vegan food? How does a system like this handle a multifaceted query like that?
Now that's a fantastic multifaceted query that truly tests the system's intelligence. And this is exactly where the ReACT framework, combined with RAG, really earns its stripes. The LLM won't just try to retrieve one single piece of information. It will initiate a sequence of thoughts and actions. First, it might think, okay, I need to verify the original Tokyo flight delay and the Seoul cancellation, then find the next available flight to Tokyo.
Breaking it down.
Exactly. It will then act by querying the relational database for flight schedules and delay information via the retrieval service. Its observation from that action might reveal, okay, the next available flight is indeed much later, implying an overnight stay is likely. Next, it thinks about the need for a hotel and a vegan restaurant near the destination airport, Tokyo in this case. It then acts again, perhaps querying the vector database for amenities and locations near the Tokyo airport. It might even call an external API for current restaurant listings and specifically filter for vegan options.
Using these external tools.
Precisely. Its observation brings back potential hotel options and a list of vegan-friendly restaurants. Finally, it combines all this information. It might even go back with a clarifying thought and action. Does the passenger prefer a specific hotel chain or price range? Any particular cuisine style beyond vegan? Before presenting a comprehensive, personalized response that addresses all parts of the original complex request. This iterative, dynamic problem-solving, where the AI constantly assesses the situation, acts to gather information, and learns from the observations to refine its plan, that's what makes it a truly intelligent agent. It moves far, far beyond what a simple, scripted chatbot could ever do.
So beyond just this demo, how does this application address broader, critical, real-world information retrieval needs for businesses? It seems to solve some really fundamental AI limitations.
It absolutely does. It directly addresses several major challenges. First, it overcomes the limitation of outdated responses. Unlike unaugmented LLMs that rely solely on static, stale training data from months or years ago, this application actively retrieves current information from external sources. This ensures the answers are always fresh and relevant. Second, it significantly mitigates the risk of hallucinations, that generation of incorrect or fabricated information. It does this by grounding the LLM's outputs on relevant external knowledge retrieved through RJ. This ensures that the responses are factual, accurate, and trustworthy, which is absolutely non-negotiable for enterprise applications handling sensitive or critical information.
You can't have your customer service bot making things up.
Exactly. And a key strength, truly vital for businesses, is its ability to provide domain-specific, relevant responses that are precisely tailored to an organization's proprietary data.
The internal knowledge.
Yes. This is a critical feature for intellectual property protection and maintaining competitive advantage. For many businesses, their competitive edge lies in their unique internal knowledge. Their specific processes, their private customer data, their research findings, which traditional LLMs trained on public internet data simply cannot access. By demonstrating a robust mechanism to integrate LLMs with proprietary databases, the genai-databases-retrieval-app illustrates how companies can safely and effectively unlock the power of Gen AI for their internal, sensitive, or highly specialized information.
Without exposing it publicly.
Precisely. Without exposing it to public models or requiring extremely expensive, bespoke custom model training for every data update. This capability is paramount for secure and strategic enterprise Gen AI deployment. And this makes the application highly suitable for a wide range of what you might call knowledge engine use cases, allowing employees or customers to easily get answers from a company's internal data, whether it pertains to HR policies, complex compliance documents, detailed product specifications, or, as we saw with Cymbal Air, comprehensive airline and airport information.
So as we look at the bigger picture here, the genai-databases-retrieval-app really stands out. It seems like a robust demonstration of how to construct these production-quality generative AI applications. Its core strength, it feels like, lies in its comprehensive approach to overcoming those inherent limitations of large language models we started talking about.
Indeed, by systematically integrating Retrieval Augmented Generation, RAG, and the ReACT framework, the application ensures that AI-generated responses are not only factually accurate and current, but also intelligently interactive and capable of complex problem-solving. This architecture directly addresses those common challenges: factual inaccuracies, outdated information, and the inability of raw LLMs to interact dynamically with real-world systems or data. It really moves beyond just a proof of concept to a truly viable solution that feels ready for enterprise-grade deployment.
And what about the architectural excellence? You've highlighted the modular design a few times as reflecting a deep understanding of enterprise-grade software requirements. How does that translate into tangible benefits like scalability, security, and performance for a business putting this into practice?
Right, that modular design with the separate application retrieval and database services, it confers substantial practical advantages. First, for scalability, it allows for the independent development, deployment, and crucially scaling of each component. This separation of concerns is really a hallmark of robust, maintainable, and adaptable Gen AI solutions, which are absolutely crucial for long-term operational success.
So you can scale just the parts that need it.
Exactly. For example, the retrieval service, which handles data access, can scale independently based on how many data queries are happening, separate from the computational demands of the LLM application itself, which might scale based on user sessions. It also supports those production best practices like connection pooling and caching to improve throughput significantly. Second, regarding security, that intermediary retrieval service plays a vital protective role. It manages authentication and authorization, acting as a secure layer between the LLM and potentially sensitive data within the database. This prevents direct LLM access to credentials and enforces granular access controls, significantly mitigating risks like those jailbreaking attacks we mentioned. This strong security boundary is critical for protecting proprietary and confidential information in enterprise deployments. It gives organizations peace of mind. Essential for trust, absolutely. And third, for performance, we touched on how LLMs generally perform better when given smaller, more specific tasks, which the retrieval service facilitates by mapping actions to predetermined, optimized queries. Furthermore, the ability to intelligently query multiple database types like vector for meaning and relational for structure can minimize overall retrieval time by leveraging the strengths of each data store for the right kind of query. And finally, the database layers designed for interchangeability offer significant flexibility in data storage choices, allowing seamless integration with existing enterprise data infrastructures without costly migrations. These architectural choices collectively reflect a deep understanding of what it takes to build robust, maintainable, and adaptable Gen AI solutions, ones that can withstand real-world loads, protect sensitive data, and evolve over time. It moves these systems beyond simple demonstrations to truly impactful, reliable systems.
So wrapping this section up, what does this all mean for the future of AI? Is this truly a blueprint for something bigger than just enhanced chatbots or knowledge engines?
I think it absolutely is. The genai-databases-retrieval-app should really be seen as a comprehensive blueprint for developing far more sophisticated AI agents. Its demonstrated ability to handle domain-specific, real-time queries through the Cymbal Air assistant illustrates its immediate business value in areas like enhanced customer service and internal knowledge management, for sure. But this type of architecture paves the way for a new generation of AI applications capable of much more complex problem-solving and automation across various industries. It really transforms how businesses might interact with their data and their customers, moving from simple question answering to intelligent, active participation in complex workflows. It's about AI becoming a true partner in tasks that require not just knowledge recall, but also reasoning, planning, and action. Hashtag tag outro.
And that brings us to the end of another deep dive. We've certainly journeyed a long way today from the initial excitement and, let's face it, the inherent challenges of raw large language models,
Mm.
to the really elegant solutions offered by combining Retrieval Augmented Generation and the ReACT framework. And we've explored how these are bolstered by a robust, multi-layered database architecture that's clearly built for the real world.
Yeah, to quickly recap the key roles, generative AI provides that amazing ability to create novel content. RAG ensures this content is grounded in up-to-date and accurate external knowledge, making it trustworthy. And ReACT empowers the LLM to reason, plan, and execute actions, transforming it into a truly intelligent agent capable of complex, multi-step problem solving. All of these components relate through that sophisticated orchestration where the application layer manages user interactions and directs traffic. The retrieval service acts as that secure and scalable gateway to diverse databases. And the database layer provides the essential foundation of knowledge, flexibly adapting to existing systems.
And we saw this practical utility brought vividly to life in the Cymbal Air demo, showcasing real-world solutions for dynamic information retrieval, from finding coffee near a gate to checking live flight schedules. It's really a testament to building truly reliable and intelligent AI that can address the nuanced real-world needs of businesses and their customers. As we wrap up this deep dive, here's something to consider.
This project really shows us how LLMs are evolving. They're moving beyond being mere language generators into becoming true intelligent agents capable of acting and reasoning within complex environments. So the question to maybe ponder is, what new enterprise problems, perhaps ones currently deemed too complex or too dynamic for AI, could actually be solved by systems that can not only understand your question, but also dynamically go out, find the exact current information needed from various sources, and then reason intelligently about how to apply it, perhaps even across different languages and diverse data sources.
Something to mull over as you navigate your own information landscape. Until next time, keep exploring.